Hey everyone, Sean here, Sean Woodhouse, and welcome to Melbourne CocoaHeads number 149. It's an online-only event tonight, so hopefully you're relaxing, you're enjoying an evening full of spectacular talks after a long day of Zoom calls. I'm sure you've already had a few, so maybe fire up YouTube on the big screen and kick back on your couch and watch the talks that we have up ready for you tonight. Just some administrative things to get through before we start tonight. In the spirit of reconciliation, Melbourne CocoaHeads acknowledges the traditional custodians of the country throughout Australia and their connection to the land, sea and community. We pay our respect to the elders past and present and extend that respect to all Aboriginal and Torres Strait Islanders people today. That's a bit of a mouthful. Up tonight, we've got three talks, as I mentioned. We've got Ben Decker's giving us a talk about some coding guidelines, giving input and getting output that they've instituted amongst their team. Marco's coming up next with a talk on consumer-driven contact testing using Packed Swift. And Jake's wrapping things up with asyncifying an app. I think that's with some of the new features in the Swift language that have come out recently. At CocoaHeads, we have a code of conduct. Our community is inclusive and we welcome everybody of all diverse backgrounds. So we have a code of conduct documented on the website. If you're interested in that, you can go to have a look at the information there. If you've got any issues with anything you see tonight or in any communication on Melbourne CocoaHeads or CocoaHeads channels, like in Slack or anything like that, feel free to reach out to one of the organisers and raise your concerns there. Sponsorship. So back in the days when we used to meet up in person, CocoaHeads used to be hosted in a venue with food and drink, and that would often be provided by hosts, by sponsors, I should say. The gold sponsor for CocoaHeads this year is Itty Bitty Apps. As the CEO of Itty Bitty Apps, I guess I'm more than happy to sort of chip in and help the community that way with money to pay for those things. Hopefully, at some point we'll be able to get back together and see each other face to face in the future. And I'll be more than happy to buy people a few extra drinks or pizzas. We've got a few other sponsors supporting Melbourne CocoaHeads, including REA Group, Latitude, and Cognizant. Coming up on Tuesday, the 31st of August, we've got the CocoaHeads Drinks Night. Again, that is often done in person at a venue that's organised prior to the night. I believe it's been held virtually during lockdowns. So keep a note of that date and keep an eye out for information about what's happening for that event. Some other groups that you might be interested in checking out, as well as Melbourne CocoaHeads. There is a Sydney CocoaHeads group as well that has been doing talks online. There's the GDG Melbourne group, which often has presentations around Android development platforms and other Google platforms. And there's a web meetup as well. You can find us at melbournecocoaheads.com. We also have a Slack group, melbournecocoslack.com. There is an invite link actually from the public website that you can go to get an invite to Slack if you're not already in there. And the channel that you want to go to for tonight's event is the Hash Meetup channel. Jump in there. I'm sure there's people in there already having a chat. So go in there, join up and join the conversation in Slack. On Twitter, the handle is Melbourne Coco, so make sure you follow that user. Again, in Slack, we've got the Meetup channel. We've also got a volunteers channel if you'd like to help out with Melbourne CocoaHeads. It does take a group of people to volunteer their time to find speakers, people behind the scenes, obviously doing the AV and making sure that these live streams are actually happening and we all sound and look good. So by all means, we'd welcome people to jump in and help organise events, even if they're virtual. It still does take a bit of time, and we really appreciate the help. If you're looking for a job or if you're looking to hire people, there is a jobs channel in Slack, so you can post your jobs there or have a look, check them out. And if you'd like to do a talk, there is a speakers channel there as well. You can jump in and offer suggestions or even offer to speak yourself. Apps that have shipped this month. Ride Stats is an app. Matt Dell's released a new version of that just recently. It's a Mac and iOS app for cyclists to understand their rides. The big new features in this release include iCloud Sync and iOS and iPad OS apps. I'm sure that was a fair amount of effort to get all that shipping. And in other news, Reveal 30 shipped. That's a bit of a plug for our own product. Some of you might know about Reveal, and again, shout out to the team who put my face on the promo image for that release. Thanks for that, everyone. Reveal 30 includes some an initial batch of UIKit version 15 properties that you can edit and view. You can inspect and change text using the UI font preferred font API. There's an option to hide alignment rectangles when the view frames differ, when they differ from the frames, which actually makes inspecting SwiftUI apps a little bit easier because they tend to be offset in most cases there. There's now a preference switch to switch between monochromatic and a new set of multicolor icons for the outline view. And most importantly, there were some issues with the way that we had instructed people to start Reveal using the breakpoint approach. There's some information on the website about how to make some small tweaks to that to make sure that the latest version iOS 15 apps can be inspected properly and don't sort of lock up when you start running Reveal with them. So check that out. There's a whole bunch of fantastic new color icons there that Carlos worked on. And if you've shipped an app yourself that I didn't mention here, by all means, jump on Slack and join us in the Meetup channel and let us know about it. First up tonight, we've got Ben Deckers giving us a talk on giving input and getting output. So over to you, Ben.
Good evening, everyone. For those of you who know me, I'm Ben. For those who don't, just that same sentence again, but with my surname added. Ben Deckers, also known as View Did Appear. Soon to be rebranded probably again with SwiftUI API updates. I think someone suggested on Appear run loop. Anyway, I'd like to introduce my talk tonight. Give input and get output. I've roughly translated that from the Japanese original. So if there's any language oddities in the text, please yell at me on Slack. It's been about 2 years since I last joined talk at CocoaHeads, but what's happened? Well, in case you've been living under Patrick Starr's rock, you're not seeing the slide. Okay, that's a deck set bug. Anyway. Sorry about that. Let me go to the next slide again. So what's been happening? As I was going to say, started to say there, sorry about that. In case you've been living under Patrick Starr's rock from SpongeBob SquarePants, world executable stopped responding in early 2020, and it's still got the little spinning wheel there. And we've all had to adjust to like working from home and some pretty radical changes. I'm pretty sure, we're all still processing that. Meanwhile, 2022 is about 4 months away, and I don't want to think about that. The problems here at my current workplace in Japan, it was compounded by the fact that many of our new hires that we had just worked really hard on recruiting and putting through the interview gauntlet, they got stuck in immigration hell. They're still there, actually. They're what we say LWFH, literally working from home. They are not able to enter the country, and they are also not able to leave their own country. Furthermore, a lot of us at the time during the should we get out, should we not stage, got quite a few of us did have our sayonara sales here in Japan and left. So we became distributed as a team overnight, basically. It was 2 weeks and we'd all been from the office to suddenly working from about 15 time zones. Our teamwork, it caught fire. Let's just putting that nicely. But as of the 1st of August, I did check the stats. Our Android and iOS teams have members working in every single country in Southeast and East Asia, including but not limited to Japan, Taiwan, China, Hong Kong, Philippines, you name it, alongside colleagues in India and some in Europe and a couple of people that have just moved back to the US. So eventually our communication and individual coding preferences became a problem. I'm assuming because the context switch that one would make upon entering the office was no longer a thing. And we sort of, all of us really reverted back to the old ways. And it just got worse and worse as time went by. PRs ended up in limbo and stylistic decisions were argued about on Slack, which was not a great taste for any new joins. So we had to bridge the cracks. So lest our productivity continue to nosedive and morale along with it, the senior team, we had to put our heads together, all our digital heads together. We had many Zoom meetings, hence the good microphone and the good camera, because I was having a lot of them. We just had to come up with an architecture for the app as well as our code review and our general guidelines that we didn't actually have before. It was like this pandemic just kicked us, sort of put a firecracker down and was like, okay, you're gonna have to adjust to this. The solution we came up with had to assist us in onboarding juniors as well that just graduated from local universities and international universities. So keep it super simple. KISS was our number one requirement. And as I said before, it wasn't just coding styles that we had to bridge the cracks with. It was during our one-on-ones, more and more of our junior members were saying that language used during code review or in messages on Slack were being misconstrued. And that became something that we couldn't ignore any longer. So the first thing we did, we started using the IO method. And I've spoken about this before, and I'm a huge advocate for it. And basically, it reduces the interface for a view model to a push button approach. So it's represented here by the protocol. You have your inputs, which is did tap login button, and the output is like, in the case of reactive Swift, an observable that you will listen to and react to and push up like the login button, the login screen, and go from there. It allows everyone on the team, regardless of programming background, to understand what is the trigger and what is the result for a given action, rather than each individual view model having its own bespoke implementation. We had to make it rigid and easy to adopt. So a concrete example of our inputs. Here you'll see I've got a what we call a Gidgee view model, a sample view model here, with myself as an IO observer here, which I've written in reactive Swift, with an input as myself, and I'm reacting to something on that when this view lifecycle event would get called from the view controller. So I hand off each event from the view controller to my view model, and all my data goes through here, 100% of it, and allows us to increase our unit testing as well. You can see the output from here as well. So on view did appear, want to do some foo and send the output update view with the content struct that is just somewhere defined. It made the cracks a lot easier to deal with. We built that bridge with the pattern. We thought about it. We found the original implementation with the Kickstarter, I think, iOS app. But the initial implementation as defined by that GitHub library was a bunch of protocols for each view model. So a protocol for the inputs, a protocol for the outputs, another protocol for the view model type, and it was unwieldy. We thought we needed to simplify that, so that's when we came up with the single one. We increased the testability of our view models, most importantly to 100%, because aside from the coding styles and language issues that I mentioned were starting to come up, we had abysmal test coverage, and people were, like all of us really, were guilty of sort of not doing as many unit tests as we probably should have done. And I'm happy to report that our code coverage has gone from a dismal 12%, which made me physically want to cry, to 62% in, there's a kanji left in there, sorry about that, in about 3 months. So we're on the upward trajectory with that, which is, I'm really happy to report this. My personal little goal for hopefully by the start of 2022 is, almost at 2021 there, this year's gone too quickly, to get to 100%. That's my personal little goal, but I don't want to say that because I don't want to bring everyone down if we don't hit that goal. Through many one-on-one meetings over the past few months, we have found that the pattern that we introduced is easy for juniors to grasp, and the turnaround time for a bog standard pull request is like way down. We went from an average of 5 or 6 open pull requests when we were working in the office. That was like the maximum if we were in a busy week. People were like logging the reviews and doing all of that. It went to an average of like 43, which isn't great. And as I said, the discussions on Slack were starting to get really stressful. And because we introduced this protocol-based approach, it eliminated the personal opinions that each individual engineer had. We sort of made that protocol our de facto impartial third party, and allowed us just to keep moving, because we were like, well, if we've got a problem with this, we can't talk to it because it's not going to talk back, so let's fix it. And we're happy to report that juniors were no longer feeling overwhelmed and were able to contribute successfully. That was the biggest hurdle that we were faced. As I mentioned before, that language was starting to become a thing in one-on-one meetings, and as you can see, it's like, do you sense my tone? Is what I'm asking in the title of the slide here. On Slack, tone is really hard to, and in GitHub as well. So the tone is impossible to read from text without liberal emoji, and if it's like a more serious topic, you tend to, I find it's a really hard line for us to toe. So we've gone from you should delete this to this variable looks unused, we can delete it because we are working on this code together. And that is something we knew, I guess, when we were working in the office, because we were seeing each other in person and having individual meetings. But when we were working from home, that personal, like the in real life contact with was obviously gone. So we were just down to interpreting people's typing, which it wasn't going well. So we have got a new policy: use as many emoji as possible, and I'm a little bit embarrassed to report that that I myself have added 2,300 emoji to our Slack over the past few months. And a junior engineer recently just uploaded his his entire country's alphabet in blinking Slack emojis. So there's so many different things now. People are way more communicative, and it's not like bog standard laughing face emoji. It's more serious, and it allows it's more on the not serious. I'd say it's more on the practical side. It's really helped us fix the problems. We established the nits Q and N for nits, Q for questions, and S for suggestions on our pull requests and on Slack to disambiguate the tone as well when needed. So obviously upcoming changes to iOS and Android. We also took this architecture after roaring success on the iOS side of the code base, and we implemented it using Kotlin. So they use the exact same thing with Kotlin-based. I guess they still call them protocols. I wasn't fully involved with that, but we're still going to have to tweak the app side architecture as we move through the iOS releases coming up. When 15 comes out, we're dropping 13, I think, and 14. If I remember we're ruthless over here. We just say, update it and use it, people. But we have to make the changes. And as I said, it's an unbiased third party, so the team as a whole remains open to perfecting this and adopting the changes where necessary. There is no one who claims full ownership of this approach. which I think is like the biggest benefit that we've gotten out of all of it, apart from like enabling the juniors to contribute without requiring endless meetings or pair programming. Just because the discussions have been had and the problems confronted, it does not mean they're gone, though we've all accepted this. It's going to happen again, but hopefully these sorts of discussions will happen more organically and not in a, I didn't know how to put this in English, reactionarily. I don't know if that's even a word, but yeah, hopefully these discussions just happen and aren't just in a reaction to what was going on. We were like, we needed to do something. We were pushed between a rock and a hard place and we were being rained on. And we were like, okay, something's going to have to get done. Anyway, in a conclusion, and I think I'm a little bit under time, so I'll apologize for that. Our conclusion is implementing an impartial app architecture and a framework for PR reviews were excellent decisions, and it saved us from losing a lot of good talent and making the working from home or literally working from home situation even worse than it could have been. So so far so good. I'm happy to report. So I'm anxious to see how the rest of 2021 fire emoji goes, because it's a bit crazy right now given the Olympics situation here and the lack of lockdown. But yeah, I will probably report back when I can. There is a demo project. If anyone has anything to say on our approach, the URL is here and I will post it in the Slack later. If you have anything to say on our approach, if you would improve it or change it in any way, let me know. I want these productive discussions on GitHub. I love Melbourne, obviously I'm from there, but I haven't been able to return in 2 years. So if yeah, I'd love the input from my fellow Melbourne engineers and to build this architecture out to truly epic proportions, something that we can share across the board. Just an aside, the demo project uses Combine and Swift UI with 0 third-party dependencies. Pretty proud of that. It took a while for me to teach myself some Combine there, but that's about it from me. Thank you for listening, and everyone stay safe. I'm going to handball back to Sean.
Cool, great. I think we've still got Ben's slide on there. Oh, there we go. So yeah, look, if you'd like to continue the discussion around how your work has changed during lockdown, working remotely, a lot of things have changed for a lot of people. You're more than welcome to join us on the Slack meetup group after this live stream to continue the discussion. I'm sure everybody there would love to hear strategies and approaches for smoothing over some of those difficult remote discussions that might happen in either on Slack or on GitHub. Up next, we've got Marco giving us a presentation on consumer-driven contract testing using PackSwift.
Thanks, Sean. Thank you for having me as well. I'm here to talk about something that I've been working on for the past year, on and off, and hopefully it will help other people get their testing with end-to-end testing a little bit abolished and not rely on it as much, but we'll see. A little bit about myself. I work with Itty Bitty Apps crew. That's enough about me. Into the presentation. So what I am planning on presenting to you today is how we are normally verifying the integration between APIs. what the actual problem there might be, what stems from it, what we are dealing with, and then go into what contract testing is, and hopefully show a non-breaking demo. But first, let's be honest, programming is really cool when you're programming alone, but if somebody is watching you, it's not going exactly to plan, so heads up. The normal API integration modus operandi, how we're normally dealing with, is quite a lengthy process, and we've been burned quite a lot in the past. And it goes something like this. In order for us to test the flow through the systems, we need all the systems involved up and running, right? For us to see data request going into, and in this case, into API gateway to hit something in the backend and then come back. If we want to test this, we need all of the systems up and running in a end-to-end ready test environment, which is okay, but that is generally slow because we need to wait for everyone to deploy. We need to all pretty much work on the same feature at the same time and deploy at the same time. All of these microservices here, as an example, need to be deployed correctly, configured correctly. Even if they're not final versions of the software, we still need a version of them that integrate between each other. So we at the end, because we mostly on the mobile apps work on the clients, only then we can see if our thing works. This is also very fragile because if one of these systems is down or not up to date or deployed correctly, we don't get to test our stuff at the end of the chain. Then comes in data management. If we are setting up our end-to-end tests with some reliance on data, we're pretty much sure this will break next week when dates change or when perhaps amounts change that we hard-coded to verify and so on. So that's quite painful to go through and see where it's actually breaking. We have test environment management in here because we need this environment available for us to run the tests. And the more systems we have involved, the more people we need in there as well to help us out and debug where things are breaking. Coverage, how do we cover this? Hard. And of course, we need to, like I said, we need all of it deployed and pretty much at the same time. And we're not necessarily all developing on the same feature at the same time, especially in big corporations. So why is this not ideal? We are coupling the release and our tests. In order for us to verify that we are integrated with the backend systems, we need everything coupled up and deployed at the same time. We are spending a lot of time on managing environments and being idle, trying to figure out what's happening, what could be breaking if things break and so on, instead of developing. This means that because we have too many systems, we have a slower pipeline leading to batching of releases. And with this batching, more failures and defects are exposed and introduced. We have deployment risks. Again, things can go wrong when we deploy. We might not configure things correctly, and we need to wait again. We introduce separate testing teams that might not understand what is implemented in the backend systems, what is possible to test, what needs to be tested, and what is an actual bug or not. We end up with release manager to help with the teams, the new teams, and everything else to be managed, to govern the entire process, to gatekeep releases and so on. And lots of times when we are seeing the end-to-end tests being done, lots of ad hoc change requests are put in just in order to verify that end-to-end test comes through, which is again not great, and we are accumulating debt. But all of this would be okay if we were testing a monolith, but obviously we're all working on, well, most of us probably are working on clients that are integrating with a lot of microservices in the backend. So this approach does not work for that. How does our integration process and API development normally work? Well, we get together, we start talking about what we need, what we need to expose, and we talk with our backend developers to prepare a Swagger or something, define how it's going to be behaving, what we're going to be, and on the client side, what we're going to be developing against, and what the provider will be providing us in the end. Hopefully this is all fairly accurate. Normally it's not, and hopefully, and in cases when backend relies on automated Swagger generation, we can't really get the accurate Swagger up front, so it's not pretty reliable. We go on and implement and deploy the provider, so the service. We test using our own mocks and fixtures, well, on the provider side, which is good. Test the provider, nothing wrong there, right? But on the other end, we implement and deploy the consumer that also has its own mocks and fixtures that eventually they do drift apart and they do not match and sync with the backend fixtures anymore. Of course, the software is never finished. We do improvements. We test against updated mocks and fixtures. We deploy the changes. Hopefully nothing breaks, but we never can tell, can we, until we are in a integrated environment. Well, lots of times we end up with a fire that we need to put out, figuring out where the data has changed, what the configuration was missed or something like that, and we're just dealing with repercussions. That's where contract testing can come in. Specifically consumer-driven contract testing. It's a technique for testing an integration point by checking each application in isolation. With this, we're trying to remove the need to deploy all of the systems, all of the integrated systems in the whole ecosystem to be up and running, and only test the boundaries of our client, of our consumer, with the next provider in line. We can do that with defining a contract and sharing that contract between the consumer and a provider. So let's look at this environment that we've seen before. Instead of relying on data and testing the whole flow through, because honestly, we don't necessarily care how microservice B and C is communicating and if it's integrating correctly or what's flowing between them, if we are only working between iOS system and the API gateway, right? So we can and should be able to split this up into isolated integration points. Define how those integration points look like, what are the required inputs and outputs, what are the expectations of the communication, and based on that, test it, hopefully locally. The benefits of this is it's simpler because we, as let's say iOS developers, only care about our integration towards the API gateway. We don't have to necessarily deploy, and we only test that point, nothing else. We don't have to have dedicated test environments. We run it on a dev machine. We'll see how we do that later. And we have fast feedback as well for the responsibilities on our side as consumers. Instead of waiting for everyone else to do everything they need to do in order for us to test our integration point that is completely detached from anything else. In this case, we can also have tests to scale linearly. We don't have to rely on all of the other systems to do everything else and put in tests for them. And we can deploy services independently, given the contract is not broken. So that what that means is if we would have microservice B and iOS app there talk to each other, or API gateway, if everything is fine, even though the backends are still working on another version, new version or so on, we can still independently deploy if we are not breaking the version that we are integrating with. So why consumer-driven contract testing is it helps us and provider team develop only the feature that consumer needs. So normally when we talk about how the provider would expose APIs, they go in and start working on a lot of different functionalities, exposing different data sets and objects. Instead of going ahead and exposing things and working on things that are not needed by their consumers, consumer only tell the provider through a contract what the consumer needs, and that's only the thing that the provider can work on instead of spending more resources and time. With this, we can catch situations when a service provider and its consumer implementation is becoming compatible. So that's the point on the fixtures drift. As soon as we start adding more features into the APIs, we should be able to test them and verify them quickly. We can catch it on developer's machine. Instead of going and deploying everything and waiting for all the systems to deploy, be ready to run a simple test, we can catch this running on a local machine before even deploying a breaking change. With this, we can have independent, but yet still coordinated integration testing for both consumers and providers. When we do not do contract testing itself, we normally use fixtures to only test how we consume the API responses, but not necessarily what is actually sent out of our environment. With Pact and Pact Swift, we can do that as well. We can have a shared understanding defined in a common document, so a contract, and we share that document and it's actually testable. Using this contract, we replay requests and play responses on which we can assert our test cases. We can also reveal unused interfaces. On the provider side, for instance, if they have multiple clients and only require through contracts a subset of functionality, that unused functionality can be dropped, deprecated. We don't have to worry about it. Less bugs, less code. It's always good. And because all of the contracts hold the information who the parties involved are, we know which clients, which interactions we are breaking and could be breaking before we deploy, and we can inform those involved parties at breaking changes in coming in, and they can fix it before deploying. Consumers can develop, so for instance, iOS app developers can develop against an API, actually running the network calls and testing that before APIs are deployed. We can do that with stubs, but this one is actually shared. So the providers know which consumers to notify about must-have breaking changes, thing that I was mentioning before. We can improve, and that has been shown with where Pact has been introduced, that communication between front-end and back-end teams, because there were less breaking changes or surprise changes, surprise breakages, teams started talking to each other and working together on APIs and letting other teams know that things will be breaking before they deploy breaking changes. The pack broker in this whole thing is another really great thing that gives us the ability to map the relationships between our services and consumers, and also tracks all of the versions of the contracts and verification results for them. I'll mention that later on as well. There's probably a lot more benefits of consumer-driven contract testing as well. These are the major ones. Grabbing that in, it's like it just lets us sleep at night, assured that we don't release something that will break through the night. What is packed? Essentially, packed is a specification that defines the contract structure. It defines what goes in and how it looks like, what is required, so the implementations of them know how to talk to each other, how to replay requests and how to replay responses. It's implemented in more than 10 programming languages, and it started at REA in 2013 when they had a problem with changing microservices, and this was their solution to figure out how to reduce their reliance on the end-to-end testing environments. The contract would look something like this. It includes the name of a consumer and provider, so the relevant parties, and it has a set of all the interactions that the consumer is expecting the provider to have available. It provides us the description of the state, description of the request, of the interaction. It defines what the required state for this interaction is, so we get expected tests on the provider side. It defines a request that is expected to be sent by the consumer, and this one is then replayed on the provider side. And it defines the response and how the mock service responds, and with a few generators or matching rules, how the verification needs to be carried out. We start off, so we have consumer and provider, we have our unit test, and the first thing with the consumer-driven contract testing is we define our unit test and we test our behavior against provider mocks. As a consumer, we define that behavior in the mock and record it in a contract. Contract is shared with the provider, be it through a pack broker or handballs through a folder or somehow. Pack broker is definitely better, but it can be emailed as well. The contract then replays those requests that are captured by the consumer to the provider when it's running either in tests or on the real thing, and verifies that all of the requests that the consumer is expecting have a response that the consumer is expecting as well. And both of these can be tested in isolation. They don't need to be on the same machine. They don't need to be in the SIT environment or wherever. They are on developers' machines or on CI. A flow of implementing a new feature can be, as an overview, can be done like this. You build a new feature that talks to the backend API. We run the unit tests. We generate a contract, and that is shared to pack broker. With a tool called Can I Deploy, we check whether the provider has verified this new contract. And in this case, no, because it's a new feature, it's a brand new contract. We're not really allowed, or we shouldn't be deploying with confidence because we don't know whether the provider is doing what we are asking them to do. So we stop there, but nothing is actually stopping us. We can still ignore it, to be honest. On the provider side, a webhook might be set up that would notify the provider to run tests with the new contract. Tests are run, the verification results are published back to the pack broker, and nothing, in this case, nothing breaks. Fantastic. We can go and deploy the provider, and through a pack broker, we can notify the consumer that it has been verified and we can deploy it. For instance, in a PR merge, we can run the test again. We tag the version of it. We publish the contract again to pack broker, which one was deployed. Let's say it was version 1.2. Can I deploy? Ask again, the pack broker. Yep, they verified it. Everything's hunky-dory. We deploy. Nothing should break in production nor sit. Or a new feature on the provider side is implemented, refactor or something's happening either way. Build, run the test, grab the latest contract that the client is defined as a release, verify the results, share the results back to pack broker. Can I deploy because nothing has broken? Yep, provider can deploy changes without, or refactor things without breaking the flow. Cool. Let's jump into our little demo, and I will show you that I have two very simple projects. One is an animal service provider built with Vapor 4. It's very bad because it doesn't follow conventions, and that's intentional. I also have a very simple animal client. There. Animal client that makes simple requests for animal object and species object. I am going to run this animal service. Is it running? Not yet. It's running on localhost 8080. Yep. And I am going to ask for all the animals. I have no animals because I did not seed the database. Nope. What species? I have species, but I don't have animals. I'm going to stop this. And redo. I'm using Docker for Postgres database. Start, reset it. Seed. There we go. I'm going to start this service again. Hopefully I get a Mary, an alligator Mary as an animal. I can create an animal. I can also get one animal, specific one. Again, Mary. I can get all the species of this animal. It works, right? Cool. On the client side, what I need to do in order to test create a contract is literally just bring in a framework called GitHub Swift. That's fine. I'm going to add it to the test target because that's the only place I care about it. And this is how a pack test in iOS looks like. We define a mock service. We define the expectations for this specific path. And we say define what this interaction will be named, so the provider side can look it up and see what's happening. And on packed broker, we can list them out as well, and straight away from the top, we can see what's expected, what's going to happen. We define or promise what our client will send out. With this test, I define that I'm going to be sending a GET request to path API animals. And when this happens, when the API gets this request, I expect it to respond with 200 and a list of animals with a minimum amount of 0 elements. I run the test of my animal client. I pass it in my base URL. I pass it my method that I've set here and my animals endpoint that I defined down here. So it always should go localhost, whatever it's going to be, API, animals, path query, and so on. Super stupid, but it works. Also, I defined that all of the contracts will be written in my project directory temp folder. Let's see what's happening there. Animal client, temp, remove animal client, done. I will run this. It should pass. That succeeded. Should have started the simulator before, but that's okay. Testing, still testing. There we go. It's going to run it. It's going to shoot off a actual request to localhost, which is an in process server that is provided by Packed Swift. Sean, I need a better computer. There you go. Animal client, test passed because this was actually sent out and this was as a response, and I tested it here as well, that the Mary was the thing that was passed back. And here I have a animal client JSON contract. I'm going to share this. I'm going to copy this into shared, two down, shared contracts. I don't know how to computer. There we go. And I'm going to jump onto my provider service, and I'm going to be running a packed verifier CLI directory shared contracts. This is the verifier that takes the contract and replays that interaction to a port 8080, which is my server running now. Everything is fantastic. Everything is cool. What my client was expecting, the provider is providing. Cool. All right, now let's move on to more development and develop more tests. Something complained somewhere. There we go. Cool. I have many more tests now for different requests, going to animals actually going for species and so on. And I'm going to run this. No, I won't. I'm going to restart this. I'm going to rerun the test. Now it's going to add all of these interactions into the test contract. What they do is really just defining different interactions, get requests, post requests, mostly get. There we go, there's a post as well, that it defines that when I call a post and species the same with this header, this body will be responded back with 201 and so on. So my test on the client side passed. I'm going to copy it again. I'm going to go onto the provider side in the service, and I'm going to test them again. Let's just see if it's running. No. Starting on, yep, cool. Oh, no, it's not integrating correctly. With this, the a request for alligator Mary returns a response which has a status of code 200 failed, and at the bottom I can also see why it failed. It did receive a request, but the response was 404. Why would that be? Because the provider is not exposing a animals API, but animal. All right. Let's change this. Better. Stop it. Come on. There we go. Starting again. Cool. Running. Run verification again. Yeah, still nothing. See, that's what I said at the beginning. Did it run properly? No, still not running. Fatal error. Address already in use. Okay. 6807. There we go. Start again. When I stopped it before, apparently it did not release the port. Cool. Now it did. Run the verification again. Okay, cool. The list Mary is returned okay, but we still have a problem where a list of species does not return the correct body. We have 0 length, but the client is expecting at least one object to be returned. So what this gives us is that communication between the teams to go back and, hey guys, you're asking for something a bit ridiculous, because we can have a category that has 0 objects to return. So you are asking for something that cannot be necessarily good. All right, I go back to the client. I change the contract, I run it again, I update the contract. Running. Mine will still be okay because the tests that I define here, when a mock provider will respond with 1 object, and I will test against that. But as a verification, like the contract tells the verifier, the provider, that you can also send 0 responses back. All right, let's share the, where am I? CD temp, copy animal to that. Cool, I've updated it, run it again. Everything is hunky-dory. We are integrated without having an integrated environment up and running outside of our local development. Happy days. This is obviously only on my developer machine, but with the CI and automation and everything in place, we would share this through a packed broker and automate all of this pretty much to the T. and it would allow us to catch all these breaking changes or not meeting the contracts. I've been working on this packed Swift framework that does not require any extra installation of mock servers or anything like that for the past year, mostly during Tour de France. But what's coming next is verification for the provider at the unit level testing, not like demoing now with running the actual thing. Finding and fixing bugs, because this is a V3 and it's using a shared Rust code for mock server. And there's a pack specification V4 coming out eventually, and I need to start thinking about that soon. Thank you for tuning in. You can find more about this at GitHub Surfer Packed Swift. That might be moving on to Packed Foundation soon, or someone else digging into Packed, go to Packed.io. And if you're keen on developing a Packed implementation, you can start looking at Packed Foundation, Packed reference. I'll be around. Lurking in Melbourne CocoaHeads Slack. Hit me up. I'll answer any questions or just raise issues in the repo and I'll get on it. Thank you. Back to you guys. Sean.
Hey, great presentation there, Marco. Very in-depth, and I'm sure Marco would appreciate any help or assistance or any questions you've got. Jump on Slack and hit him up, or I think he's on GitHub as well, so you can reach him there. Next up, we've got Jake giving us a bit of a story about how he asyncified his app. Take it away, Jake.
Hey guys, thanks for coming. My name is Jake. Today I'm going to talk about how can we use async to rewrite a whole app. So I'm a mobile tech lead at REA, and before we look at this, how can we use async, and then I talk about what is this app and why I'm doing that. So here's some background of this thing. Here, about a year ago, and then I got a request from a publisher and asked me to write a book. So, this lockdown day, we have fun to do. So I decided to write a book, and it took me 9 months. So this book including for 34 chapters, including how to build up a unified development environment and how to have a standard GitHub and Git flow, and on the other hand, we also show up how to build some common components like a design system. The buttons, all this stuff, and routing system is very important for an app, particularly for multiple teams work on the same app. Also, how to support some tiny things, but very important, like dynamic types, dark mode, and localization, all this stuff. And another chapter, I just talk about your app design and architecture, including BFF. It's similar to the API gateway, what Marco mentioned before, and how to use something like an MVVM to make the app easy to contribute, and using reactive data flow to make it unit text very easy, like what Ben mentioned, like input output. So the last part is talking about like automation and using single command to manage all these certificates and profile, and how to distribute the app using CI/CD, and also after go live, how to optimize the app using analytics, watching, crash report, A/B testing, remote go, anything. Right? I'm not selling the book here because it's written in Chinese anyway. But to make this book very practical, and I decided to write an app. Okay. So I write an app called Moments, and open source as well. So you can look, if you're interested in look at the app on GitHub, and the app comes with everything. Like usually the production app will have like a GitHub flow and like a branch management, and also come with a CI. So every time I push, and then you automatically build it, and also distribute to test file, also distribute to file-based app distribution. And also I have a design on Figma, anything, just like a production app, but small version. So let me demo how this app looks like. And then I bring my simulator here, and I hope my machine can still working. Alrighty, before I run it, I just crash it. And you can see I have 3 different apps there. Actually, it's only one app, but have 3 different schemes and using different configurations. So something called debug, and debug version is like alpha, and also have the internal version for internal stakeholders, like a product managers, or someone like a QA, they can look at them, and also production version, which is App Store version. So I'm going to demo one of these. One is internal version, because internal version come with something called internal toggle. So we can turn on some feature and before we ship something. So this is the app, they call Moment. So the idea is from the WeChat Moment, and pretty much very genetic ideas. So it's like a timeline, and you can actually fade, you can dislike, something like that, and then you can follow someone, and so that pretty much this is the app. And at the end of, okay, I changed my slide. So at the end of this book, and I have a very like a bold idea. How should I do better, right? So at the end of the book, and then I decide to try to text out my architecture, and is it actually flexible enough or extendable enough? So I decide to queue. So I'm using, by the way, I'm using MVVM pattern, which is a model layer, view model layer, and view layer. And in the view layer, originally I'm using something UI kit, which is we use it for 10 years, and then I decided to use Swift UI. So I replace it from UI kit to Swift UI, and without changing any single line of code within the other layer. For example, view model, which including view model, repository, routing, tracking, networking, data store, and nothing has been changed except for the UI. So I tried to approve the concept. I didn't know I can work it a lot, but it worked quite well. And then I'm going to show you the outcome of that. So which is, if I go on one of the internal toggle, right? So I can turn it on, and basically I crash the app, start from scratch, and then I reopen the app again, and it will give us a Swift UI version. And then which is looks a little bit better than the UI kit version, and it comes with a lot of animations like this thing, like a parallax effect, and then comes with something like called new skeuomorphism design, like this thing, a slightly very silky button here and there, and it talked to the exactly same backend and only change the from the UI kit to the Swift UI. So I have this app, and then I demonstrate the book, and then this year, 2 months ago, and then we all know about WWDC 21, and then I decided to learn something new, like async and away, which is within the Swift version 5.5. And I used to be a .NET developer like 10 years ago, might be more than that, and also a JavaScript developer, develop a lot Node.js stuff. I do like async a lot, and I use it a lot, and that's a very, impressed me because I can use the best feature within my favorite language, which is Swift. So the best way I learn, I'm going to do something, which is implement my app in a new way, which is Swift 5.5 way. So I'm going to demonstrate the app to you guys. That's what I have done, which is different simulator. You can see there's a 15, iOS 15, and I can still show you the other one, which is the 14 one. So you think about this as Swift UI 1.0 or 2.0, whatever you call, I don't know how to call it. And this is Swift UI 3.0 probably. So pretty similar. Didn't take me long time, just like a three or 4 nights, something like that, night time. And then I re-implement it, and using total rewrite from scratch. So you can see the very similar effort, but slightly I feel like the new one is better. And then you can see some experience. If I kill the app, right? I kill the app, I show you some experience. So I start the app again, which is Swift UI, the latest one. You can see spinners there, something like that, have a placeholder if it failed to load. And all this one is faster. So they're actually using the exactly same BFF, which is a backend system using GraphQL. So you can see this one slightly slower. I don't know why, but I feel like this one slightly faster, something like that. So then I'm going to show you. I move all this simulator out for now, and I'm going to show you how I re-implement the exactly same app call moments. And the first thing is I'm going to walk you through the architecture. So every time we even write a small app, but I would like to have some kind of architecture because they can help us to maintain the code easily. So I'm very have something like an MVVM pattern because we use this pattern in our production app as well. And we can use the similar pattern on iOS and Android. And we also can have very clear data flow, and all the code, most of the code, without the UI part, we can unit text them, almost 100% cover them. And then, so to write a new app, I start trying to follow similar pattern, but of course they are different. So if you look at the other one, the old implementation, I'm using like Arc Swift. And then every time I get a data, I just use observable or subject to publish it. And then, but in the new app, I decided to have zero dependency. I mean, zero third-party dependency. So I only use the Apple API, and I found out that actually is mature enough for me to use. So basically, in the model layer, I use something called encoder and encodable and decodable, which is a part of codable. Depends on which direction. So I don't want to use just codable. I want to use encodable for one direction, and other direction is decodable. And it chat to the GraphQL BFF. It's the same BFF. By the way, I also open source the BFF as well. And then it comes with some contract things. So hopefully I don't easily break them because they have a schema. And I have a networking layer. So in the networking layer, there's a best place, I feel like. So because they come with I/O, so the best place to play with async and away. And after that, so I have something called repository. Repository is something like a single source of truth for the entire app. So I'm to make it, to manage the states, the mutable states. So I use a new feature called actor. And then on top of that, there's a view model. So anything textable in the view model and prepare the data for the Swift UI to display. And I use observable object, and here I use state object, something like that. I can walk you through the code, and then, but bear in mind, this is what I'm using. So you can see there's like a single line up and down. And then if you look at the code, here I'm changing to Xcode, which is a beta version. It might crash in some time, but it's pretty mature and stable at that when I'm using it at that moment. And then if you look at something, so I have something called features, and then so that one app can have multiple features. In the future, we can have something check-in feature, whatever, or payment feature, something like that. So within one feature, I have a slightly small like an MVVM pattern. So if I look at from the bottom up, and then the model layer, which is the data. So the data, exactly presenting same as the BFF schema. So I have a BFF here using GraphQL, and the GraphQL dispose the contract, which is a schema. If we define the data type and the nullability, and then I pretty much match whatever the BFF schema give to us. So like something, if the title is nullable in the schema, and then I mark it optional, something like that. So, and I have a nested data. So basically, this data is pretty much matching to the UI. So because we call it BFF, because we try to make the BFF smart enough to talk to different backend system, whatever microservices, and then they prepare the data for the app, which is iOS platform or Android or web, to display correctly. So if you look at that, we have something called user details. We're presenting the top part, and then it has an ID, name, avatar, and background image. And we have something called moments, and then we can have multiple moments, and which is become an array. So the array will have data like this, and then they also have the moments have something like the avatar, the title, something like that, and then or someone like it, and then we tap on it, so this array became changed. And then there's the data model, super simple. Anything is decodable because the data comes from the network, which is BFF. So let's one layer up. So when we start the app, the first thing is really to fetch the data, right? Fetch the data from the backend, and then the fetching is the moment by user ID. So basically, I make up a BFF request here, and the BFF request, they come with a schema, like this one here. They call query, actually not schema, the query. So it means ask the GraphQL backend, say what kind of data do I want. And if you look at that, they're also presenting, the data here. So I want user details, I want moments, and you return as an array for me. And then I want the ID for the moments ID, like item ID, and also I want the name of the user, which is Taylor Swift, and the avatar is an open image for Taylor Swift, and the type currently I only support one image, and the title. So sometimes title is empty, and sometimes title is optional, right? So some title, and then created day. So I translate the created day to the pitching time, so make it more friendly, something like that. I can show you how to do it. Very easy, straightforward, and it's like it a lot, and then it's likes here. So I prepare this query, and then I do one request. So because I might have so many GraphQL requests, so I encapsulate something into a extension method. So let me show you guys, which is here. So which go on the something called foundation. I got something called API service, and I got an MT protocol, which is only providing function. And then if you look at that carefully, you might see something. I didn't use any third-party modifier or AAF networking, nothing. I just use Apple's provided API, which is URL section. So to make it working, using async and await. So the first thing is when I define a function, I have to define something called async. Simple enough. And then it means this function is asynchronous. And when I define an async, I can use some async API within the function. If I don't define that, it will become an error. And so if you look at that, we are using some async function here, calling the API the URL section. And if according to Apple's WWDC video, they said they re-implement all the APIs support two versions. One is synchronous version, one is async version with a similar signature, so we don't need to worry too much. and then we just use the old way we used to do, and then mark a way in front, and then they will tell you actually this is async. I don't have to do any like a completion handler anymore within the input parameter, for example. So in this case, I'm using a way to call this function, and then it will do a request to BFF and return the data in tuple, which is the data and response. So simple enough. And then because it's forwardable, so we have either to use try ? To silence swapped error, or try to refloat it. So I decided to not throw it, and then I decided to not allow. I want to refloat it, so that's why I have a throws in my signature of the function. So if that's failed, it will throw here, for example. And on the other hand, actually, I can do something. I can handle it by myself. For example, if I do the get the data, and then I try to decode the data to my domain object, which is I showed you before, which is this object. And then if it fails, and then I can also throw my like a more specific error, which is a error type enum, extend, how to call it, confirm to this protocol, error protocol. So depends on how you do your error handling. This is a play around app. I haven't actually thought very deep on how to do error handling yet. So there's something I throw, something I didn't. I suddenly found out you shouldn't be doing that. And you might see. So if I show you that again, if this is loading up the data, right? So, but you can see I actually try to update the data as well. So if, for example, I like it, it will update the backend, the BFF. So how can I update the data? You might see in the networking layer, I have something called like updater. If you look at those two types side by side, they look almost exactly the same with different input parameters and with a slightly different, they call query or mutation. So in GraphQL, we have query to query data, we have mutation to update the data, we have subscription to broadcast data. So we just use something called mutation to try to update. And then on the other hand, GraphQL can also, even you update data, you can get the data back as a JSON. So there's something different from the RESTful API. We used to have a post and update data and don't get any data back, but or only get the status back, for example, 200. But on GraphQL, when you're updating data, you can also get the data back. So I exactly define same data structure, and then I will report the data to my UI. And then you can see anything very similar, also calling this extension method to do the data request. So we already have some networking layer, and then on top of that we have repo. So repository basically a single source of truth. So you can imagine our app, we might have multiple screen using the same data, or we might have different user. The user is updating the button like this one here, and on the other hand, the network request also requests the backend and sync the data. So basically, the repo is a single source of truth. It might end up some of the situation called race condition. So if we end up in a race condition, we might have something like, for example, unexpected bug, or some of the unexpected behavior, or sometimes even crash the app without any hint, because we have to reproduce it based on the user situation in a concurrent way. So how can we avoid those things? So Swift 5.5 give us something called actor. So basically, you can see something I define something called actor instead of class or struct. So actor, technically, you can think about in syntax, that's very similar to a class. The actor is also reference type. And on the other hand, actor have some difference from the class. For example, actor, they don't support inheritance, so I don't even need to mark it final, but I used to mark something final. I don't want to seal it. I don't want someone can inherit from it anymore. And also, actor can handle all the requests. For example, a function call in a way, which is messaging instead of a memory. What's the difference between them? So if you think about it, it's a class. When I pass in data into a class, a function, and it will pass the memory. But on the other hand, when we use actor, it will pass in a message. And then actor, think about just like a receiver. So it receives message one by one and handle it in a way, avoiding the the mutation of the state. So using actor can help us to not write the code using block-based code to avoid like a concurrence. So it helps a lot because I feel like it's super straightforward. You can write your code like similar like what you did before for class, but you mark it actor and then automatically get the benefit of that, and then without writing logs. And it made your code this existing pattern, but get the benefit of it, which is great. So if you look at that here, so we have two functions within the actor. One is called get moment, which is that when I start the app, I get moments. Another one is simple enough called update like. So when I hit the button, it will, okay, sorry, maybe I broke myself here. So I hit the button and then you will call this function, and then you can see all those functions, they are all async away. And they also flow if there's any error. So on top of that, remember there's a single source of truth, but it means there's a multiple caller or multiple consumer can use it. One of the consumer is called view model. So why instead of I just directly using view, and the reason I introduced view model because we can fully unit text view model, and it's very difficult to text a view. So I like to have a view model always to convert the model data to a render ready data, which is a UI render ready data using view model. So in this case, I have a view model called moments timeline view model, which is presenting the entire screen. And then within that, I have a repository, which is we just mentioned before, it's an actor. And then when we try to load up the data, we just go to the repository, and then the repository will figure out the data for us. Either go to network, which is our BFF, or go to the local storage, for example, like a user default or core data or whatever magic they do, and then return the data to the view model. And then we do the manipulating within the view model layer. So because we are displaying two different types of data, one is the user profile, the other one is moments item. So I have two different sub-view models doing that. And then you can see the profile one. So if you can see the profile one is super, okay, I bring it like this. And then you can see a profile one pretty much mapping whatever from the model, which is from the BFF, to the UI ready data, which, for example, we have an ID, you always have an ID, do something like an identifiable, then we can use in a for each in this fifth UI. And also we have a name to display, which is here. So we get it from BFF and pack it in the name. And also we convert. So you think about the BFF, they return primitive types, which is string. So I just convert it into a URL. It's variable though, so that's why that's optional. And then also convert the background image to a background image URL, which is display ready data. So that's how I use view model. And on the other hand, there is another view model. It's a little bit more complicated because there's more data I need to convert. So for example, this one is presenting one moment item. So it has an avatar URL, blah, blah, blah. That's so simple. But we also have something, we try to convert the time into something like a more human vendor readable time, for example, 6 minutes ago. So what I did is I passing in the even a dependence anything inject, because that can help me to unit test everything. So I even pass in the now. So in the actual implementation, we just return current time, and I also passing in the relative data datetime formatter. So which you also can dependence inject when we do unit tests, and then it will help us to not end up some time zoom issue, for example. And then you can see this function is fully testable, and also the view model will provide some functions, so actions we can do. And then, for example, in this view model, we provide something called like and like. So when we do like and like, we call in this the single source of truth, which is ripple again, using the async away way. So, but you might notice something called main actor, right? What's main actor for? So main actor basically annotation to describe this function or this type. You can make a main actor on top of the class instead of a function. But I try to make it as small as possible, and then let the other part run on whatever queue they are. So let's talk about this thing, because we are using an actor. So when I do a request within the repo, they will dispatch to another queue. It probably is a background queue, and then if something happened in the background queue, and once I get the data finishes, for example, getting the 9:53, and then when I try to do an update to the UI, for example, 9:54, you can see likes, which is a publish property here. So if I update this likes, it means there's an object wrapper for the publish, and then it will update the Swift UI. If we don't do it, we don't do a main actor, and then it will update in the background thread. It will either crash your app, but actually Xcode in this here, they will tell you, oh, you try to update the UI using background thread, something like that, to help us to find out the problem. So the easy way, one way is we can use something like a dispatch queue.main.async to dispatch the execution back to the main queue. On the other hand, we can do something simpler and what Swift 5.5 provided to us, which is called main actor. So we mark it main actor, and then automatically we'll dispatch back to the main queue. And then this peace of mind, we can do our code like a synchronous way, as we used to do, and then remove all the headache to think about how can we dispatch, where should we dispatch, all this stuff. And then let's move on to the top part, which is the UI part. So you can see here is the UI, and then the UI timeline view pretty much presenting this UI. And then we have a scorer view, and then we have items. So it means we can pack in any kind of item in future, and like usually like a Twitter or Facebook feed or something, the other similar thing. I got a message, sorry, might be over time. Yeah. Sorry, let's continue. So basically you can see I have a timeline view, and then within the timeline view I have a repeatable item. That's why I make some of the view model, they are identifiable, because I want to put in the for each. So they need to have an ID. And within that, so I try to display item, generic item. But if think about Swift UI, any view, they are a protocol. So you cannot have an inheritance or something called polymorphism. So what I did, just like I have a generic view, which is here. So I go there, and then that generic view will detect what kind of view model it is, and then it will display the view for us, right? So if there's a user profile view model, I try to display user profile view. Otherwise, I display a moment item view, for example. So simple enough. I have a user profile view here. right? So I'm going to show you some of these things. How can we do this like a quite slicky animation? Very straightforward. So I have a view model. Pretty much I have the data I can display, and then you can see I make we stack whatever stack, and then you can see this item floating on the screen, like my name, my avatar URL. And one thing I try to mention is the async image, which is, you can see there's a new API. In my old app, I use Kingfisher to display the image. And then this time I don't even have any third-party dependency anymore, because Apple's so generous to provide all the components I need. And then you can see here async image, and then we can customize it, even have a progress view. So you can see if the image is loading, we can got the spinner here. Sometimes it's too fast, sometimes you can't see, but just pretty much you can see the spinner here. Might be streaming a little bit slow. And if something failed, it will get a red, but you better to do it better. So get a red here. And then once we get the message, and then we can display it using normal way to the Swift UI components. And then I show you how you can do this like a parallels thing here, right? So there's something called, I put two background here. The first one is I got a blob. The blob thing is we go to the exact thing here. It's just a random shape here. But once I put those two blocks there, and then I put some offset and put some rotation effect, and it looks quite shiny for me. And then I got another image, background image, and then you can see those things floating around. And when I drag in it, so I have a state, which is state. When I drag in it, I just change the scale effect, from 90% to 100%, something like that. Also have some notation 3Ds, and then it will give you some nice animation here. That is how we do that. Super easy. And in terms of doing in UIKit, it takes a lot more longer for me. That is how we done this animation, and I'm going to show you the last bit, which is the moments item. The moments item, I implement this thing here. It's like a silky button here, right? So in UIKit, we might need to implement the entire thing for ourselves, but in Swift UI, it's much easier because we have something called toggle. So if you look at this toggle, and then within your toggle, you can specify your style for the toggle. So it's like a like toggle style. That is my implementation here. Just up there, so you can bring it to a separate component, but for me it's super straightforward. So within the toggle, there's a button here, and there's some background color. That's it. The background color based on your highlight state. The background color also implement here, which is some gradient color. And then when I press them, and they have a small like a silky animation. And pretty much that is how I implement this app, but the presentation is not finished yet. So okay. I hope John couldn't cut me off. And most important part for tonight, we're hiring. So we hire iOS, Android, lead dev, different level, senior, mid-level, whatever. If you're mobile dev, feel free to contact me if you're interested. And we are one of the Australia best workplace to work for. Actually, we are the #1 in the local company. We're #4 in that kind of best workplace, but the top 3, they are all international companies. So we are #1 in Australia. And we have a very great team. I'm very proud of them with diversity. So you can see we have different gender, different accent you already listened to, and different culture background, anything, different expertise, Android, iOS, some come with backend, BFF, something like that. So we have a very good mixed team together, and we work on all the iOS and all the IA apps, including realestate.com.au, Real Commercial, and Ignite apps. We work across iOS, Android, and BFF, so we don't call someone iOS dev, Android dev, or BFF dev. You can see anyone mobile devs. We work on many products. If you join this team, you work on half of the mobile product in IEA. And something made us special. We have something called CI Friday, Continuous Improvement Friday. It means you can use 1 day a week to whatever you like to improve our developer experience, optimize the process, and enhance the user experience. So, which is the end of the talk. And if you're interested, find me in the Slack, or you can go to my GitHub and you find my details there. I don't use LinkedIn that much, so if someone connect me, I might take a month to get a accepted connection. But if you go to GitHub, you find my detail. You can directly chat with me via email, or email my IEA email. If you're interested in the app that I showed you before, which is the link here. And thanks for coming. And I'm going to hand back over to Sean and share.
All right, thanks, Jake. That was an awesome talk. As somebody who's been out of the code for a number of years, I kind of feel like I can now go in and do some PR reviews of all my staff, and I'm sure they'll really appreciate all the things I learned tonight about async await and tell them to use all that cool stuff. So no, I'm just joking. I'm sure they'll tell me to get out of the code and keep running the business, not dabbling with their stuff. Just to wrap up tonight, I'd like to thank our sponsors, Itty Bitty Apps, Latitude, REA Group, and Cognizant. And I'm pretty sure pretty much all those companies are hiring as well, if not all the other companies doing iOS and Android development in Melbourne. So be sure to check out the jobs channel in the Slack. Let's see what's next. So we've got just a reminder that the CocoaHeads Drinks Night is coming up on Tuesday, the 31st of August. I'm sure a lot of you will be desperate to get out of the house and catch up with people face to face. So that might be a big one if we're out of lockdown, but we'll see how we go. Thanks for joining us. Now, just remember there is a meetup channel in Slack, and there'll be most likely a Zoom link posted there. And I'm sure a few of us will hang back there and have a bit of a chat about tonight's presentations. Thanks for watching, and we'll catch you next month. Cheers.